Okay, so a really important part of meteorology, or understanding the weather, is to be able to read a weather map. So if you have a weather map sitting in front of you, there are a number of things that you will need to understand about that weather map. Okay, on the weather map, you're going to see high pressure represented by an H, and around an H, or a high pressure system, the air in the southern hemisphere is moving in an anti-clockwise direction, or the opposite way that a clock hand will turn. The low pressure, well, that is the opposite, and it travels in a clockwise direction, and that's represented by a big L. So the isobars, or isolines, are spread 4 or 5 meters millibars apart. So we'll look at that on a map shortly, but all the lines all over the map represent the lines being joined of the pressure readings in those areas. So if they're really close together, the lines on the map are really close together, the pressure gradient's really strong, and therefore you've got wind, strong wind. And another thing to note on when you're reading a weather map is air being dragged up from the south is going to be much colder, and if it's been pulled down from the north, it'll be warmer, and sometimes bears a lot of moisture too when you bring it down from the north. A front, which is represented by either the triangles, the blue triangles, or the roundish red marks on the line as well for the warm front. So we'll have a look at all of those things. So we've got this weather map here, and this is a good one because it kind of represents we've got all the things that we want to see on a weather map. We've got the high pressure system here, we've got the low pressure system here. So the high pressure system associated with good weather, the low associated with bad weather generally. And if you look at these, all these marks around the place, we've got a cold front here with represented by the blue triangle on a line, and here's 2 warm fronts coming out of the low pressure system here. The warm fronts represented by this red half circle. So easy to remember, warm is red and blue is cold. So cold front, warm front. You can see how close the isobars are here. So these are the lines which measure the wind, and that's basically the air moving from one place to another. So these are quite close here. So that means it's really windy. And remember I talked about the low pressure system. It moves around, the air moves around a low pressure system in a clockwise direction. So if we move around, we're going around this way. So the wind is going this direction. Okay, so it's going this direction, quite strong. So if you look at the map underneath here, you've got New Zealand, and if north is straight up, then the direction of this wind down here is about a northeasterly. So that's how you can tell the direction of the wind by looking at a map. On the other side of it, down on the South Island here, we've got this high pressure system right here. The pressure reading is 1025 hectopascals, and the air moves anti-clockwise around a high pressure system. So we're talking about going this direction now, and around this way. Okay, so and then moves around this sort of way. It's spinning in that direction. Yeah. So when you're going that direction, around here, not much wind, long way between these 2 lines here, long way. So it's quite a long way. So that means there's not much wind, much pressure gradient. The air is generally moving in a northeasterly direction. And down this area here, the wind gets a bit stronger, and it's more of a nor'wester here, straight northerly here, and coming more westerly out sort of way southwest of New Zealand. So you sort of see how we work that stuff out. So all of these numbers here are representing the pressure, so the air pressure. So when the air pressure is low, we generally have negative weather, high pressure, and the weather is not so bad, it's usually quite good. Okay, so here's just another example of a weather map. And you can see there's quite a nasty weather system around here. This nasty weather system is a low pressure, probably close to either the remnants of a tropical cyclone or what they call a subtropical depression. So it's another word for a low pressure system, is a depression. And here's a great big high out in the middle of the Tasman, so or even over Australia. So lovely weather over here around the high, and pretty nasty weather right over here around northeast New Zealand. And you can see there's cold fronts. There's a change of air here with the fronts. And 978 hectopascals is the pressure in the middle of that low there. 1023 in the middle of the high there. So basically the air wants to move straight into the low, but because of something called the Coriolis force and the spinning of the planet, it means that the air always gets turned to the left. So air comes out of the high and then gets turned to the left in the southern hemisphere. It's the opposite in the northern hemisphere. So around this way it comes, and around and around, and it comes out, and then it starts getting pulled into the low in a clockwise direction. So it comes in here like this. Yeah. Terrible drawing, I know. You get the gist of where I'm going with it. Out of a high into a low. So a low is essentially sucking air, and it gets sucked up into the upper atmosphere, whereas a high, it's got pressure from above pushing down on the surface of the earth, and that air has to go somewhere. It can't go through the earth, so it goes out and gets forced out in that anti-clockwise position, in the direction. This is a slightly different weather map. You can see it's actually a GIF. It's moving. You can see the movement of the weather, the low pressure systems coming. There's a high right over New Zealand moving off to the east, and in comes a low. So you can sort of see, we can just watch that for a minute. And then from the west over the Tasman Sea and crossing the country, creating havoc, and then the low moves off to the east. And that's a general pattern that happens a lot with New Zealand's weather. Okay, so we're looking at a slightly different weather map here, but you know, it hasn't got so much of the details around highs and lows. But if you look here, here is 980 hectopascals. That's a low, so the air is moving in a clockwise direction around that, and there's not actually any high pressure systems noted there, but you can see the direction of the wind is and these things here, these little markers here, are how strong the wind is, and they generally work that you have a long or a short tail. You can see a short tail on this one here. So the long tail is 10 knots and the small tail is 5 knots. So here 35 knots, 30 knots, 25 knots, that's the half one, 25 knots here, maybe that's a 30. So there's lots of, you can sort of see the direction of the wind, and you can work it out from the way the air moves into a low. Slightly fuzzy picture this one, but you can sort of see slightly bigger scale. Obviously New Zealand, Australia off to the left there, to the west. You know, what you find is that you get a lot of big high pressure systems hanging out over Australia, and just south of New Zealand you get these quite big subantarctic lows, and sometimes they move up and affect the whole of New Zealand, and sometimes they sink south, and sometimes you'll get stuff happening up in this region up here, up in the tropics and Pacific Island. Those there can be low pressure systems that work their way down over New Zealand and affect particularly the top of the North Island, but it can also affect right across here. So they descend and you get lots of rain coming from the tropics as well. So to look at this weather map, pretty straightforward. There is a low pressure system here off the coast of Australia, of New Zealand, off the west coast of New Zealand, and that is advancing this way because nearly all of the weather in New Zealand comes from west to east. We get it most of it from Australia or from that direction. Sometimes it sort of descends down from more up in the north, and sometimes it'll come from here, but nearly always roughly from a westerly direction moving along. So this low is going to come across and hit New Zealand, particularly the west coast of the South Island. There's a front right here that's come out of the low. That'll mean we get heavy rain up and down the west coast, and as this moves further to the east, moves across, you find that the wind direction will change. One thing that happens on the back, this area here of the low, on the back, of course, the direction of the wind is south, and if air comes from the south, it's dragging it up from Antarctica essentially, or definitely colder areas. So you therefore end up with a change of air mass, and therefore a change of air mass is a cold front. Or if you're getting a warmer air coming from further north, usually you've got a warm front. So cold fronts generally get spawned out of the colder areas, because that's where a cold air mass, and then warm air comes from the more northern areas. Again, just another weather map showing directions of wind. Quite a nice big high across New Zealand, and right up here to the east, over the kind of the nearest, well, not that near the Chatham Islands, but off to even to the east of there, you've got a low pressure there and another low pressure system coming in. So the weather here, it's quite nice, but it's all moving this direction. So if it moves that direction, we're going to get that low pressure system hitting New Zealand. Another weather map here, big high above New Zealand, impacting mostly on the country. There's a whole lot of high centres. So you've got this one here and this one here. There's a low out here, but as you can see by the direction and the spaces between these isobars, there is not a lot of wind around New Zealand at this time. This would be a classic summer pattern. Not much wind, a few high centres. There's a bit of rain coming in onto the west coast here from this low pressure system, but it's not a particularly deep low. There's nothing major going on as far as weather's concerned. If you look further south, you can see that the isobars are much tighter down below here, around this region here, much more wind. You can see by the more bars represented on these representations of the wind strength. And you can see 992, so the pressure's dropping, and that's going down to a big or a deep low further down in the Southern Ocean, which would be impacting all that weather going on down there. Okay, so this is a mapvid weather map, very useful website, and it's essentially the same. In the orange there, you can see the isobars. They're all noted there in orange. Very useful if you go to the website. Not shown on the slide here so much, but they give rainfall rates. So if it's clear, these areas like out here, no rain. The pink areas here, that's kind of light drizzle, getting into blue there, slightly more steady rain, darker blue, more rain, moving into the yellow, heavier rain again, and then the centre here, heavier rain again, right to the red colours. So the red colours, which we don't have on this map, is that kind of very heavy torrential rain, which can happen with big weather systems, particularly coming into the west coast here. But mapvid, really good. One thing to note, the measures of wind strength. So here, the wind is actually, so you've got a low pressure right here, so it's moving around. So the wind direction is actually from here. So it's different from the other maps. The direction of the wind is from this way here. So it's a southwesterly there essentially. It's 25 knots and it's going towards the circle, okay? It's going towards the circle, so this way here. So this way here, yeah? And this way down here. Okay, so you can work out the wind direction and strength by these by these little markers here, and they give subtle little directional changes in the wind around based on the highs and the lows. Often you get weather maps in black and white, so that's why things like the black markers for the cold fronts are slightly different shape from the warm fronts that you get here. So yeah, slightly different. That one there is actually a stationary front with the triangle and the half circle. But it doesn't need colour as such, and you can still read quite a bit of information. It's got the numbers, so not hugely strong winds, but steady winds, low pressure system right over kind of the Cook Strait sort of area, Taranaki Bight, and a big high pressure system down in the Southern Ocean below Tasmania, working its way in, and probably impact on the lower part of New Zealand. Very simple looking map. Sometimes you can get decent information out of that. You get a high, you got a low. Essentially, there's a front in there. Very, very basic stuff, but that means rain for the west coast. A bit more complicated. This one, you can still see the shapes of Australia and New Zealand in the green with the green outlines, but pretty complicated weather map there. You've got a pretty deep low, 976, down below New Zealand, causing all sorts of nasty cold air to be dragged up from the Southern Ocean, causing all of these cold fronts to sweep in. This is a classic winter snowy weather system. And if you look out to the far to the southwest, we've got an even nastier system here with a 968 hectopascals in the middle of it, just here. So this one here is going to move its way across and potentially create even more snow. So this is your ski field payday, when you get all of the snow comes all at once. You get two systems like that. It looks like there's another one's just passed through. Loads up, so much snow up through here and up through the sort of central plateau of the North Island. So these are big snow event. That's a big snow event map there. Back to the other style of map that the Met Service are using quite a bit. You can see the wind strength, a bit of a low pressure system below New Zealand again, and there's a bit of a high pressure system just up over Australia. In between is New Zealand with that generally that westerly flow of into the coast here. And whenever you got wind coming off the sea hitting the land, you generally get this representation here in the yellow and the green of heavy rain in that lower west coast area. Okay, back to the MetView map. This is a good example of a nasty weather system coming across the top of New Zealand, working its way. Probably it looks a bit almost like a tropical cyclone, at least a decaying one. 896 even. No, 984 is the centre of it. So 984 here. That's the red there is really intense rain. So full on rain, flooding. There's a bit of flooding up there to the northeast as well. That there looks like it's moving in this kind of direction. So the that sort of weather system can impact on the right across the North Island, mainly the far north, right down through Taranaki, and also the lower part of the North Island and the top of the South Island can also bear the brunt of some quite nasty rain and strong winds, as you can see with these measures. 35 knots. I'm seeing is it 40 knots just here. So 40 knots. That's a strong wind. Just very quickly, another simple map. This is probably a summer situation. You've got a nice big high, 1,032 over New Zealand. This is really settled weather with this system here, this low pressure system moving its way, but with such an intense low, this 1,032. There's a good chance that this might slide down a bit below New Zealand. It can do this sort of thing. So just be aware of that it can that when you're trying to forecast in that sort of area, it's really hard to to tell if you've got a very intense high, whether that low pressure system will actually even make it, or it'll just sit out in the Tasman and decay and sort of get sort of swallowed up by the high, if you like. So usually it'll get there eventually, but it might be a severely weakened system by the time it gets there.